All right, y'all. So today we are starting a new unit. That's unit 11. And this unit covers a variety of things. A lot of the unit deals with circles, and a lot of the unit just deals with the area of different shapes in general. So this unit is called the area and circumference unit. So circumference is only to do with circles, but the area part has to do with a lot of different things, including circles. Now, that word circumference, we should have heard that before. And the first thing that we know about the circumference is it is the distance around the outside of a circle. It is the distance around the outside of a circle. And the distance around the outside of an object of any shape is the perimeter. So the circumference is essentially just the perimeter of a circle. And you may recall that the formula for circumference is 2 times pi times the radius. And so if we have our circle with our circumferences all the way around, the way we find our circumference is using that formula. Circumference equals 2 pi r. So let's say we have a circle where the radius, let's say, is 7 meters. So to find the circumference, we would go through the process of just plugging in that 7 to r. R is our radius. It is halfway across the circle. Now, something else that you need to know is that the diameter of a circle is twice the radius. The diameter is always 2 times the radius. So this is our radius here. This entire side is our diameter, and the diameter is always twice the length of the radius. So the diameter is 14 if our radius is 7. But we don't want our diameter, we just want our radius. So in this equation, C equals 2 pi r, circumference equals 2 pi r. We can plug that in. C equals 2 pi times 7. And that should give us 14 times pi. And if we put that into our calculator, there is a button for this. So second, and then the pi button. If you're not sure on where to find the pi button, it is directly below clear, but you have to push second first. So second, and then the button right below clear will be pi, and then say times 14. 14 pi gives us approximately 43.98, which rounds to about 44, and that is in meters. So basically the circumference of this circle, or the perimeter of this circle, is essentially 2 times pi times the radius, which gives us 44 meters. Since that is a distance, that's not squared, it's just meters. Now, the new thing that we're learning in this video is the arc length of a circle. And an arc is just a curved distance between 2 points on the outside of the circle. So for here, we have a distance from A to B that is called arc AB. So this is arc AB. And we use that little curved mark to denote our arc. But that's not the most important thing. The most important thing is what the actual value is. And the way we can think about an arc is it is a fraction of the circumference. So the circumference is the distance all the way around. We can measure an arc by taking a fraction of the circumference. So, for instance, if our arc was halfway around the circle, say it started here and went all the way around, or halfway around. Our arc would be half of the circumference. So we take our circumference, 2 pi r, and we multiply it by that fraction, whatever that fraction is. And the way we do that, the way we find that fraction, is by plugging in the angle measure that it gives us. So theta, remember our theta from last unit, over 360. Theta over 360. So if our angle, if they tell us our angle is 70 degrees, that basically says that this piece of the circle is 70 degrees. This arc is 70 out of 360, which gives us our fraction. So the arc equals 2 pi r times 70, excuse me, let's put theta. Theta over 360. Two pi times, let's say our radius is still 7. So 2 pi times 7 times 70, which is our theta, over 360. And plug that into the calculator. And we know our circumference already. We already have that from our previous problem. So whatever our circumference is, times this proportion of the circumference. So 70 divided by 360 is about 0.194. Multiply that by 44, and we get about 8.55. And that repeats, so that's about 8.56 in meters. So that is a proportion of our circumference. 70 out of 360 is just shy of 20%. 8.56 is approximately 20% of 44 meters. And that's the arc length of a circle. So let's take a look at a couple more examples. I'm going to do one more with y'all, and then the other 3 on this page you should be able to answer on your own. Let's start with number 1. We know that the arc equals 2 pi r times theta over 360. And then we plug in what we know. The arc equals 2 times pi. We're going to leave pi there for now because we're going to plug that into the calculator later. Times our radius, which is 7. Okay. Times theta, and our angle is 90 in this case, out of 360. So this is 1/4 of a circle. This is a quarter of a circle. Plug those things into the calculator, and we have about 10.99 kilometers, which rounds to approximately 11 kilometers. So if you did not get that answer, pause the video, figure out why, look through this example again, and then move on to the next 3. I'm going to go ahead and give the answers now. So if you're not quite done, pause the video, finish these 3 problems, or finish one at a time if you feel like you want to do that. and then answer these. Make sure you got the same answer as me. So the arc of number 2 equals 57.85, which rounds to about 57.9. It's in centimeters. Number 3, the arc is about 10.47 miles, which rounds to about 10.5. And in problem 4, our arc equals about 39.26 kilometers, which rounds to about 39.3. If you got all of these correct, great job. You're well on your way to doing this stuff well. If you missed any of these, go back, figure out why you missed them, look at the first example to see how these are done. In our next video, we'll be looking at how do we find the sector area of circles. It's a very similar concept.